Okay, welcome back to Statistics. Again, this is DSRT 734 class. In these lectures, we're going to continue with our regression concept. And in this lecture, we're going to study the measure of regression and also prediction intervals. Our goal here is calculating the residuals and also finding the possible best fit regression line. So our main objective is to interpret the three types of variation about a regression line. Again, interpret the three types of variations about a regression line, which is the concept of residual, the errors. Also find and interpret the coefficient of determination. Also, we are going to find and also interpret the standard error of the estimate for regression line, and also construct and interpret the prediction interval for Y. So first, we start with the variation about regression line. We have three types of variation about a regression line. One is the total variation, then explained variation, then unexplained variation. Again, we will go through all the three one at a time. So this again, the three different types of variations about a regression line. We have the total variation, explained variation, and unexplained variation. Now, to find the total variation, we must first calculate the total deviation. Then we find the explained deviation, then unexplained deviation. Again, we will go through what is a deviation and what is a variation. So a variation about a regression line, first we're going to find the total deviation. As we said earlier, in order to find the variation, we need to find the deviation. So a total deviation is, if we remember the descriptive statistics, when we are looking for standard deviation or variance, the first thing we do is that we find the mean of the data set. Then we subtract the mean from each value. Then we square it. Then we add all together. We divide by the number of items minus 1 if it's a sample. Then we find the square root of it, which gives us the standard deviation. Now, to find the total deviation, the same concept. Now, we have to subtract each value. Here, we are looking for Y, so subtract. That's why we say yi. I can be from 1 to 10 if we have 10 values. So total deviation is finding the difference of each Y value and the mean of the Y. Now, to find the explained deviation, now you are going to find the difference of each predicted Y value and the mean. So the mean value is the same. We are going to subtract the mean from each of the predicted values. So if we have 10 values, then we may have 10 predicted Y values. So we subtract the mean of the Y values from each of the predicted Y value, and that gives us explained deviation. Total deviation again is subtracting the mean from each actual Y value, So Y caret is the predicted value. Now, to find the unexplained deviation, we are going to also find the difference between the Y value, the actual Y value, and the predicted Y value. So we can see that unexplained deviation is almost the same as finding the error or the residual. The residual will be the difference of the actual Y value and the predicted value. So again, the total deviation is the mean of the data set subtracted from each of the values, the Y values of the data set. Explained deviation, subtract the mean of the data set from each predicted Y value. Then unexplained deviation is the difference of each actual value minus each predicted value. So here we have our X and Y. So X is our independent variable, the X-axis. Then we have the Y-axis, which is our dependent variable. So if we have a linear equation, this is our linear line. The predicted value point is on the line. Then we may have actual value blue here. So we can see that the predicted value will be the xi and y carat. Then we have the actual y value, the blue. So the total deviation, and also let's say we're assuming this is our y average when we find the mean of all the actual y value, this is where we get the mean. So this means the total deviation will be the difference of what? The actual y value and the mean. So this is the total deviation. Then unexplained deviation will be the difference of the actual y value and the predicted y. Then explained deviation will be the difference, again, between the predicted y value and the mean y. So now we know all the deviations, all the three deviations, total, explained, and unexplained deviation. So now we can be able to find the variation among the regression line. So to find the total variation, we say the sum of the squares of the difference between the y value of each ordered pair and the mean of the y. Now, the reason why we square, because we said this earlier, if I find the difference of the y value, this is the actual y value, and the mean of each of the actual values. When we sum all, we may end up getting 0 because some of the difference will be positive value, some of the difference will be negative value. So it's the same concept as finding the standard deviation or the variance. We find the difference of the actual value and the mean, then we square it, then we add it to the next value. So if I have two y values, it will be y1 minus y mean all square plus y2 minus y mean all square plus, then we keep going because that's the sum. So this will give us the total variation, the sum of the difference of the actual value and the mean square. Now, explained variation will be the sum of the squares of the difference between what? The predicted y value and the mean of the y. So we have the again. So we can see that this formula is the same as explained deviation, but in deviation, we don't square. Variations we square. So explained deviation is what? The difference of the predicted y value and the mean y. Square will give us explained variation. So that's what we have here. Predicted y minus the average y all square. And that will give us explained deviation. The same thing applies to unexplained variation. It will be, I would say, unexplained deviation square, the sum. So it will be the difference of what? The actual y value and the predicted y all square, and the sum of it. So the sum of the explained and unexplained variation is equal to the total variation. So total variation is always explained variation plus unexplained variation. So next we move to the coefficient of determination. Normally, coefficient of determination will be the ratio of the explained variation to the total variation. Explained variation to the total variation, the ratio. So this is the formula R square equal to explained variation over the total variation. Now, sometimes the R will be given. If R is given, then we just square the R. We square the R value. We don't need to use this formula. But when R is not given, then we have to use the explained variation. After we find the explained variation, we find the total variation, then we divide the two together. We get the R square. And the R square always gives us the percentage of the Y value that was explained by the independent variable, let's say the X value. So we can see the example here for coefficient of determination. They gave us the R value already. So here the question said the correlation coefficient for the advertising expenses and company sales data as calculated in section 9.1. This was the previous session we did. We found the R. This is when we are finding the difference between, or the relationship between the company expenses for advertisement and related to the company sales or revenue. We were able to get the R value. Now, if I know the R value, they say we should find the coefficient of determination. And then what does this tell you about the spring variation of the data by regression line? And also about the unspring variation. So coefficient of determination tells us something. So again, the correlation coefficient for advertising expenses and company sales data as calculated in section 9.1 is R equal to 0.913. Now find the coefficient of determination. What does this tell you about the spring variation of the data, about the regression line, also about the unexplained variation? So first, we already know the R, so we just square it. We don't need to use the formula as I said earlier. So if R is 0.913, then coefficient of determination will be 0.913 squared. So our answer is 0.834. Now, this tells us that 83.4% of the variation in the company's sales can be explained by the variation in the advertising expenditure. Advertising expenditure is our independent variable. So 83% of the variation in company sales, we can see the variation. Based on the advertisement expenses, we have different, since the expenses are different values, the company sales are different values also. So the variation between the two expenses, advertising expenses and the company sales, the difference between the two, we can say that 83.4% of the differences, the variation in the company sales can be explained by variation in advertising expenditure, which means the remaining, say roughly 16.9% of the variation is unexplained. Should be 16.6, yeah, 16.6. This will be 100% together. So we subtract 83.4 from 100, that will give us 16.6. So we can say about 16.6 is unexplained, because if we 83.4% variation in the company sales, which is the dependent variable, can be explained by the independent variable, then the remaining 16.6 variation is unexplained. So we move to the next topic, subtopic, which is the standard error of estimate. So the standard error of estimate is the standard deviation of the observed Y values, the actual Y values, about the predicted Y values for a given SI value. So let's see what this means. To find the standard error of estimate, it will be the sum of the difference of the actual Y value and the predicted Y value square. We sum all of them, divided by the degree of freedom, which is n minus 2. So n will be the number of ordered pairs in the data set, which will be the size of the sample. So this is the standard error. Then this is standard error is the standard deviation of the observed Y values about the predicted Y value for a given Xi value there. Xi will be our independent variable. So the closer the observed Y values are to the predicted Y value, the smaller the standard error of the estimate value. Now, if even at some point we saw that the actual value of Y and the predicted value of Y are the same, then our standard error will be 0. So the standard error gets bigger when the difference of the actual value and the predicted Y value, the difference is large. So this is the steps in finding the standard error of estimate. And the goal of finding the standard error of estimate is to know, it's more or less a variation of the data of the actual Y value and the predicted Y value, how they varies. So the smaller the standard error of estimate, the better the predicted value, because the difference, which is the error between the actual value and the predicted value, is very small. So first we make a table that includes the column heading shown. The reason why, because we can see in our formula we have the value, the predicted value, and difference of the predicted and actual Y values. So first we make then we use the regression equation to calculate the predicted values because we need it in our formula. So first, predicted values are not given. They give us S and Y values. So if I know S and Y values, I can, of course, find the slope. After I find the slope, I'll find the intercept. After I find the intercept, then I can be able to find the regression equation. Now, when I get the regression equation, I'll plug the S values from S1 to S10, let's say 10 values, and I'll get all the predicted values with the actual Y values. Now, when we have it, we find the difference of the actual value and the predicted value. We square all of them. If it's 10 values, then we square all the 10 values, we add it together. Then we find the standard error by dividing the actual value of Y, the difference of actual value of Y, and predicted value, all square sum, we divide it by n minus 2. And that will give us, again, the standard error of estimate. So this example here, the good news is that here, the process is very quick. We don't need to find the slope and also the y-intercept. So they give us the regression line already. So if that's the case, we just plug in the value of x from S1 to whatever x8 to find all the predicted values for all the 8 pair of values. So use the table to calculate the sum of square difference of each observed y value and the corresponding predicted value. So we have 1, 2, 3, 4, 5, 6, 7, 8 here. So this is the values given to us, S and Y. There are 8 values, 8 pairs. Each pair is the expenses for advertisement and the company sales. So we use the regression line, the equation that we generated by finding the slope and the y-intercept. Then we plug in the S values here to find the corresponding predicted value of Y for each S values. Then we find the difference of the actual Y and the predicted Y, then we square it. Then we sum all of them, we get 635.3463. Now we should be able to find our estimate now. So it will be 635.3463 divided by the sample size is 8 minus 2. So the standard error of estimate will be 10.290. So here we say the standard error of estimate of the company's sales for a specific advertising expenses is about $10.29. So next we move to what we call the prediction intervals. Now, if we have two variables, or here we say two variables have a bivariant normal distribution, if for any phase value of x, the corresponding values of y are normally distributed, and for any phase values of y, the corresponding x values also are normally distributed. So we can see the diagram, we have concept of each normally distributed term. So this is called the bivariant normal distribution. Now, a prediction interval can be constructed for the true value of y. And we have given a linear regression. And linear regression will be y caret ms plus b. And also a specific value of x, which is the C prediction interval for y, is, remember, E is like our error. So it will be y prediction or y caret minus E to y caret plus E. That's the interval. The interval, or we say C prediction interval for y, is between the prediction with the error, minus and plus. So how do we find E? E will give us TC and SE, the standard error of estimation, times the T and C, 1 plus 1 over n plus n. SO will be given to us. We say given linear equation with this and SO minus x bar, the mean square, over n times s square sum minus s square x sum square. So we say the point estimate is y caret and the margin of error is E. So this concept is the same as looking for the confidence interval, but here we call it prediction interval or C prediction interval. So I have my prediction value minus the margin of error plus the margin of error. So that is the prediction interval. And the error is there's the formula we can use to find the error. So in words, let's look at the steps here. Then we're going to see an example also. So here we want to construct a prediction interval, which is kind of like confidence interval. But the prediction interval means I want to predict a value and the actual value, I cannot say 10. Instead of saying 10, I'll find the error and the error is 2. Then I'll say it's between 8 to 12. 10 minus 2 and 10 plus 2. So I know the value will be between 8 to 12, not exact 10. And so it's the same concept of confidence interval. So here we identify the number of ordered pairs in the data set. How many sample size we have, n. And then we can find the degree of freedom, which will be n minus 2. Then next, we use the regression equation and the given s value to find the y estimate. So we have y predict, we should know the slope and the y-intercept. Then we plug in all the s value from 1 to 8, our example. So after we get that, then we are going to use the t-table, find the critical value, which is tc. That's why we find because we are using the t-table, that's why we find the degree of freedom. We remember degree of freedom always is the rule of the t-table. So we find the critical value tc that corresponds to a given level of confidence, c. Then after that, we can find our sa, which is the standard error of estimate. We need this in order to be able to find the error. And next, we have the TC from the table. We just find our SE. We know our sample size already. SO is given. We have our X data set, so we can find the S mean. And we plug in all the value to get the error. Now, when we get the error, we add and subtract. So we say the estimate of Y here will be Y prediction minus E and Y prediction plus E. So let's see an example. Here they say we should construct 95% prediction interval for the company sales when the advertising expenses are 2,100. What can you conclude? So first, we did this example already, so we know the N is 8. This is the data, the question that we have, the company advertising expenses with the company sales. So company sales is our dependent variable Y, and advertising expenses is independent variable X. So we know the pair were 8, so we have 8N, N is 8. Then we're able to find the slope already. We get the slope and we get the y-intercept. And we also find the standard error already in these lectures. So we know the sum of X is given, S squared sum, we know it, S bar, we know it. So we can just plug in our values, get the point estimate for 2.1. Then we find the critical value. In order to find the critical value, we need the degree of freedom. So degree of freedom is 6. We go to the 6th row and we look for 95% prediction interval. So we look for alpha 0.05. So look at the top 0.05 and degree of freedom 6. You get your TC to be 2.447. Then when we get this, we can be able to find the error now. We know the standard error, we know the TC from the table. We plug in all the values. The error is 26.857. Then from here, we can find our left endpoint, right endpoint, subtract the E from the predicted Y value, and also add to the predicted Y value. So we get 210.592, which is our Y prediction, minus the E. Then we add the E to the 210.92. So our interval will be from 183.735 to 237.449. So our conclusion is 95% confident that when advertising expenses are 2,100, because we are using, remember we are using the 2,100. The company sales will be, and this is the prediction value. The company sales will be 183,735 and 237,449. So it will be between that interval. We are 100% sure based on the previous. We were able to get a regression model. The regression model here gave us all the 8 pair of X and Y, the company advertising sales and advertising expenses and the sales. Generate this for us. Also, we're able to find this from that data set. And now our prediction is 2100. So when the advertising sale is 2100, we can plug the 2100 here, but we are not, that will not be 100% value. We say 95% prediction interval. So we are not going to plug it here as we did previously, but rather we want to find the interval. And that's the process we follow. So we need to find first the point estimate, which is what we normally will end it. So this is the estimate of the, if the advertising is 2100, this is the sales we know approximate, or that's why we call it estimate. But now we want to find the interval between. So we have to use the T-table. So we find the degree of freedom. Then we go to the 6th row, that's degree of freedom. And then 95%. So our alpha will be 0.05. So go to the top of the T-table, 0.05. And then the 6th row, the T-value will be 2.447. Then we can use it to find our E. We already know the standard error. Plug in all the value. When you get your E, you subtract it from the point estimate, which we calculated first. In our previous lecture, we only predict approximate value once, but now we are predicting the interval, 95% sure that the prediction will be between this interval. So that will be our conclusion for these lectures. So again, in this lecture, it's almost continuation of regression, but here we know we use the regression equation to predict. The previous lectures, we only predict a point estimate, one value. This time we can predict an interval. So we have to understand the concept of variation, deviation for the data set. Then we also find the determination of coefficient. Determination of coefficient will tell us the percentage of the variation in the dependent variable that was explained by the independent variable. Then we're able to find the predicted interval also. After we get a point estimate, we find the margin of error, which is E. In this case, we need to find the T value using the T table. Then we need to find the standard error of estimate. Then we plug it in our formula to find the E. Then we add and subtract from our point estimate value to find the interval, prediction interval. So again, wish everybody the best and thank you for your time.